Hello everyone! We are from Group 4, Class 11A. In this video, we are going to talk about an experiment that we did about centripetal force. Firstly, the objective of this experiment is to determine the gravitational acceleration of the Earth by using a centripetal force. This experiment also aims to prove the formula of centripetal force, which is done by looking at the acquired gravity.
Before we get into the experiment, we'll start by showing you some basic theories. This experiment revolves around the concept of centripetal force. Newton's first law of motion states that an object will maintain its current state of motion unless an external force acts upon it. When an object moves in a circle, it's constantly changing direction. To keep it on its circular path, a force is required to pull it towards the center of the circle. This force is known as centripetal force.
Centripetal force could be found using the formula mass multiplied by centripetal acceleration, which is equal to mass times 2 phi per period squared multiplied by the radius.
To start with, let's see the apparatus that we used in our experiment. The apparatus that we used are washers, plastic tube, string, rubber stopper, stopwatch, ruler, marker, and triple beam balance.
With that being said, I'm going to discuss the procedures of this experiment. First, we'll have to prepare the apparatus. Next, decide the independent, dependent, and control variables for the experiment. These variables could vary from person to person. However, in our case, we decided on the following variables. For the independent variable, we decided to use the mass of the washers. For the dependent variable, it is the period, which is the time taken for one complete revolution to happen. For the control variable, we decided to keep the length of the string and mass of the rubber stopper constant throughout the experiment. After deciding the variables, we can continue with the experiment accordingly. So, for the independent variable, we should measure the mass of the washers using a triple beam balance. We also decided to create 5 variations of these washers' mass. For the control variable, we should measure the mass of the rubber stopper, which is going to be used for the calculation later. Then determine the length of the string, then mark it with a marker, then hang the washers to one end of the string and the rubber stopper to the other. Next, move your hand in a circular motion so that the rubber stopper will also move in a circular motion. Make sure that the length of the string stays constant throughout the motion. Do this by making sure that the marked spot from earlier stays in place. After making sure that the motion is already constant, use a stopwatch to measure the time it takes for a revolution to happen. Next, perform the same motion but with the other masses of washers. Lastly, use the required data and formula of the centripetal force to calculate the gravity of the Earth.
So, from the procedures mentioned before, we acquire the data which can be seen from this table. Here, we can see that there are 5 different values for mass 2. Mass 2 here is the mass of the washers, which is the independent variable. On the right side of this table, we can see the period. Period is the time taken for one complete revolution to happen, which is the control variable. Above the tables are mass 1, which is the mass of the rubber stopper, and radius, which is the length of the string. Both of these are control variables, which means that they are kept constant throughout the experiment.
In this experiment, since the length of the string doesn't change throughout the motion, we know that tension 1 is equals to tension 2. Therefore, we also know that the centripetal force experienced by mass 1 is equal to the weight of mass 2. From here, we can just simply input the formula for centripetal force and weight, and in the end, we'll get the formula for gravity, which is mass times 4 phi squared per period squared times radius divided by mass 2. To find the gravity, we just need to input the data we already have from the experiment into the formula we just got, and after that, we have to find the average for the gravity, and in this experiment, we got 10.160 meters per second as the gravitational acceleration. To find the percentage error, we need to use the formula EV minus AV per AV times 100%, with EV being 10.160 meter per second squared and AV being 9.81 meter per second squared. In this experiment, our percentage error is 3.568%.
While the percentage error falls below 5%, this error could be caused by several reasons. First, human error. The inaccuracies may be caused by the timing measurements. Furthermore, the execution of the circular motion may not be perfect. Second, apparatus error. For example, friction at the pivot point can create an opposing force that reduces the effective centripetal force acting on the object. Third and last are external factors. Factors such as air resistance acting on the rotating object will also oppose the centripetal force.
Several things could be done to optimize the experiment. These include, first, minimizing air resistance. This could be done by replacing the rubber stopper with another load that has a lower surface area. Next, we could utilize better apparatus. For instance, utilizing apparatus such as a vertical stand or support with a horizontal rotating arm will guarantee a better circular motion.
In conclusion, from our experiment, we have successfully determined the gravity acceleration using the centripetal force formula. This result shows that the formula of centripetal force is usable and accurate because the result obtained has an error below 5%. However, while small, this percentage error is most likely due to human and apparatus error, as well as other external factors such as air resistance. This could be minimized by utilizing better apparatus. That's all for our centripetal force experiment report. Thanks for watching!